Hello, everybody. Welcome, and thanks for joining me again today. Let's switch to the code view. I'll be continuing my work from yesterday, which resulted in us rendering that chain of skewer blocks, or terminators, I should say. Let's open this diagram that we generated. It looks incredibly impressive. So for those of you who watched the session yesterday, you remember that the way I implemented the render function for a drakon diagram is that I simply add the height of an individual terminator block to the accumulator, and that way we achieve the shift in the rendering process. This is why the icons get shifted down. But today I want to focus on implementing an automatic process of measuring the size of the render blocks so that we don't have to use this constant, but instead the automatic measuring mechanism. And I have an idea how to do this. For that, though, I would like to visit this type. And maybe that won't even be necessary. So the type class render I feel should be renamed to renderer. And then once we rename it to renderer, we can provide another function to it. I'm not sure this is the best idea, but it should work. And we can always iterate on it. Let's get rid of this annoying warning. This is in line 47. So technically it is not needed, but I feel if we have that bracket, the code is just easier to read. But at the same time, I'm very annoyed with that warning. So it turns out we don't even need it. So what I would be interested in is a function called size in units. Or maybe that would be an int. Um, yeah, let's not worry about that. Let's just go with int. And now I'm going to get a bunch of warnings that these functions are not implemented. We only have it available for Terminator. So for Terminators, the idea is pretty simple. So it doesn't matter what we get as an input, the output is always going to be 1. Let's see if this builds. Line 61. So let's leave this comment in. Where's this type? Okay. Same in line 70. Here the implementation is going to be slightly different. It's not correct, but it should build. Yes. No, excuse me for a little minute. Okay, I'm back. Now, let's resolve all these warnings. Oh yeah, this was not correct. So, let's start with height, because I feel it should be easier to implement. For now, let's format. So height is going to be a sum of all. Let's see what AI says. Map Okay, I think that should work. And here, the width is going to be different because we can't sum the widths because they are arranged vertically. But for future reference, some of these blocks can be wider than the others. Like, for example, when the diagram starts here, the width is probably going to be just 1 unit. But here, as it branches out, the width can grow. So I feel what would be reasonable here is to have a max instead of a plus. Yeah, this should be width. Or let's try it out. This should work. Oh, we can use some. Thank you. That's good. Can we do this? No. That's much better. So now let's try these out. We have how many blocks in the diagram? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if I do any units, yes. And instead of print, let's do show. Now let's do height. Perfect, so that works. So now all of our types that participate in the family of drakon diagram types implement this type class, meaning we can check the width and height in units of all of our components. This is going to become very helpful while rendering this. Because that single block, we can now measure its height. And we can multiply this by the full block height. And this should work. Yeah, we can't do operations between types, so we'll have to turn this int to a different type. We can still use fraction of a unit. I know I don't have to, but it just looks nicer. All right, so let's run an experiment. This should not change if I refresh the page. It's not changed. But for the terminator, let's say I want the height to be changed to 2. So now the gaps should be much larger. And they are. Beautiful. So now that we have this automatic way of measuring the, and if you notice, the total height of the diagram is now 20. That's good. So now we have the automatic way of measuring the size of each block. We can proceed to the next part. Let's check the time, 20 minutes. Maybe before diving into more complicated types like skewers. Or you know what, maybe let's do this. Let's find diagram block. No, this is actually okay. No. Okay. Now, let's come up with some skewer blocks. And for a skewer, let's select an action. Oh, sorry. So let's incorporate, and I think we'll finish here. Let's incorporate an action. So let's see what kind of instances we have. We have, you know what, maybe let's push it here. First of all, let's see if it builds. It should. Okay, that's fine. Oh, and we don't need a headline, just an action. So this will be very easy. And we're not rendering connections yet. So just for the sake of this exercise, let's say that the height of this is going to be 2. So that we can mix and match them and see like a visual distinction. Oh yeah, this is not needed now. Line 88. in line 74, we need to provide an instance for skewer blocks as well. Which should be pretty straightforward. Should they be all in one place? Yeah. Today I learned. Okay. At this instance, we don't have to touch because we already have all these three functions implemented for individual diagram blocks. Okay, so now let's mix and match. Let's make the third one skewer diagram block and action. It has size 11 because this one has size 2. Okay, so we're making a mistake. We should be directing the diagram downwards as opposed to upwards, but we can very easily fix this. By removing the height. Or subtracting the height. Perfect. So 1, 2, 3. It takes 2 spaces. Beautiful. So now let's see how much time we have. 29. So we should technically be wrapping it up, but I'm very eager to get started on the fork. So let's at least provide a hook for this so that I can continue from a known place during the next session. Oh, sorry. So that now that we have a record for a fork, we also need a record for a valent point or data type. It's just a data type. So let's provide an implementation of a fork. Yeah, so for now, let's make the fork just a bigger action. So what is tempting to me let's do 2, 2, and we'll be calculating these automatically during the next session, hopefully, or next session plus. But what is tempting to me is this render, the size of this rectangle and this rectangle should ideally depend on the size of its children, if there are any. So for now, can we just do this? Will this work? It looks like it is working. And here, this is the bounding rectangle, and here, icon height this is incorrect. Let's not use this. Or maybe it is correct. Let's make icon width a proportion of default block height. Or not. Let's not use this at all. Let's just operate in units. Sorry, this would be more appropriate. So this will be 0.5. So we know it takes half the available space. This action we no longer need. And here, let's provide the same implementation as for the action, just for now. Just with a fork. Terminator will have to get a very similar treatment. Close the bracket. Let's see if this works. Oh yeah, I made a mistake here. It doesn't matter what's in here. Oh. So now it will complain that I don't have an implementation of render fork. And we'll also have to do now action, which is defined here. It's complaining that, yeah, the argument that we're passing to, or the type parameter that we're using with the render type class instance does not exist, and it doesn't. So we'll have to provide an implementation. We can just say shamelessly copy this implementation. And instead of using fork block, we can use fork and origin. Now this becomes fork. This becomes fork. And here, for the forward block, we can just say render x origin. And now here for action, let's make the width of an action 1 because that's correct, and width of for now it's hard coded, and from the fork let's do so action will have height of 1 to bring order to the galaxy again, and fork, or fork's height will be calculated by this. So this should build if I'm not missing anything. 67. What's the error here? Oh yeah. We don't care. We don't care. We don't care. Oh, we need to construct the whole thing. Okay. Can we just do... No. X. Because it doesn't really matter what kind of fields we get. Oh, by the way, thanks to this book, I learned that these are not called properties, as I was very adamant to call them that. They are called fields, so now I know. Okay. And now I don't even have to worry about naming this. Oh no. This needs to stay. Okay. So if I run this now, nothing will change here. The total height should be 10, and total and width of the diagram should be 1. Yes, and now what I'm going to do is, just after the action, I'm going to add a skewer diagram block that is a fork. With valence points, it doesn't really matter what's here. Let's see if I can construct it like this. Brackets. So now, perfect. So we get 2 because the maximum width of, the block with maximum width in this whole list is a skewer, and that's with 2, hard-coded here. And since fork's height is 2, the item we were replacing, which we're changing the height from 1 to 2, so the total height is 11. So if I refresh this now, we should get something like this. So now we know that the origin also needs to be adjusted. Because we'll figure it out later. Yeah, we'll figure it out later, but I'm glad we have the hook for the next session, which is the fork block. And I think we're getting close to trying to represent these nested drakon diagram elements inside the fork. So excited for the next session. I don't have a good idea how to do this yet, but as soon as we fix the positioning of this, we'll get to that. Right? Having said that, I thank you very much for your attention today and for sticking with me. I hope this was entertaining or educational, and I wish you a fantastic day. Have a good one. See you next time. Bye.